that SpaceX put on Twitter, it's actually the entire single-take launch of the Transporter-6 mission, the mission that launched a little while ago, carrying 114 different payloads into space. Now, it's awesome because it's a single take of this rocket taking off and going up and doing the flip and then turning back around and coming back down and landing at the LZ-1 back on the shore. But there's so many little interesting things that you can see if you pause it, play it again, pause it, play it again. So I figured that we would do a little bit analysis of the video so we could talk about some of the things that you can see as we go through the thing. The first important thing is to figure out where this camera actually is, right? If you look at the rocket, it's actually up above the grid fins. You'll see that later on in the video, but the grid fins are just below it and it's looking down the bottom of the rocket. The first thing you'll see now that you know that this camera is up a little more than halfway up the rocket looking down is that you're looking at the pad infrastructure, right? And the number one thing is right in the middle of the screen, you see some water jets sort of going in. That's part of the deluge system. That actually starts up before the rocket engines actually light, and it's there to absorb some of that initial ignition impact. And so what you do is you put some water in the way, and that energy coming out of the engines hits that water and atomizes it, turns it to steam, and sort of diffuses and diffracts it so it's not just bouncing straight back up at your rocket. The next thing that you'll see are what's called rainbirds coming on. And the rainbirds you see across the top of the screen, and those are sort of nozzles that spray a little bit wider fan in. That comes on after the center deluge pipes come on. The act of vaporizing that water from liquid into a gas takes energy, and that is energy that's not going to come back at your rocket or go off in all sorts of random directions. Flame directions are a big part of launching rockets. Keeping control of that energy when you're close to the ground is super important. Cough, cough, Starship. Another thing that you can sort of see is the transporter erector. The TE is on the right-hand side. And that sort of leans back a little bit in advance to sort of get out of the way. But you don't want it to be right next to the rocket as the engines pass it and spray flame all over it. So what you see happen right there after ignition and liftoff is that transporter erector throws back. It's literally the transporter, the TE throwback, and it throws back even further so that the flames of the rocket engine don't directly impact the side of it. The transporter erector actually carries up some of the umbilicals, like how they fuel the rocket and how they get electrical connections to the second stage and all these different things, right? And so you want to protect those lines, those hoses, equipment, whatever. As we get off of the pad a little bit here, there's a great shot of the flame director, the flame trench that's controlling the direction that exhaust goes. Now, if you've seen that awesome drone shot of Starship doing a static fire down at Starbase, you see there's no flame trench there. It's just a flat piece of concrete underneath, and therefore the exhaust goes in every direction, right? Here at Pad 40, there's actually a built thrust direction trench, flame trench, whatever you want to call it, that creates this big directional plume out in one direction, and that sort of controls where that exhaust is going to end up. It doesn't just go in every direction and end up in all your other GSE and into your dumpsters and whatever. It goes in a specific direction. You can really see how that plume is, directed by the flame trench. As you continue to go up, you see the rocket start to do a little bit of a roll there. You can see the Space Coast in the background, all the little roads there, the beach. That's all part of Cape Canaveral Space Force Station. And so the first pad of Cape Canaveral Space Force Station that we see is over on the left-hand side of the screen. That's going to be Slick 41, Space Launch Complex 41, which is part of United Launch Alliance, where they launched Atlas Vs from and where they're going to be launching the Vulcans from. So as we continue the roll and the rocket climbs higher and higher, Launch Complex 39A and 39B come into view over on the left-hand side. Launch Complex 39A, of course, is where SpaceX launches their other Falcon 9s from. The crew launches go from there, and the resupply missions going up to the International Space Station go there, because unlike 40, which has no tower or crew access arm or anything like that, 39A has the tower and crew access arm that they can use to load, astronauts onto the crew capsule on the way up. The next pad over, 39B, we recently saw a launch from there. That's where Artemis 1 and SLS took off just a little while ago. And as we continue to get higher away from the Space Coast, we see more things start to happen. The biggest thing that you really start to see is how the fire coming out of the back of the Falcon 9 starts to change. Down on the ground, if you've ever drawn a rocket and you draw the little pencil flame coming out of the bottom, right? That happens because of the atmospheric pressure down at sea level. Down at sea level, there's all these air it's not molecules, air particles, whatever you want to call them, right? Densely packed in. It's why you can breathe pretty well when you're down at sea level. Then you go up a mountain, you're like, I can't breathe anymore. Air's not as dense. You're not getting as much oxygen. What that air does is it actually keeps the flame sort of like, I don't know, in a flame shape coming out the bottom of the nozzle. As you get higher, like climbing a mountain, the atmosphere gets a lot thinner, right? And the thinner atmosphere has less of an effect sort of pushing that flame into the pencil flame coming out of the back of the rocket. And you see what's called plume expansion. The plume starts to expand out the sides. And of course, it's a Falcon 9. It's got 9 engines on the bottom. So instead of just one big nebulous cloud behind the rocket, you actually get sort of discrete little expanding flame plumes coming out the side of it. Of course, there should be 8 of those, right? Because you got 8 engines around the outside and then 1 engine in the middle. So the higher and higher you get, the thinner and thinner the atmosphere gets, and the more and more that exhaust plume expands out behind the Falcon 9. You really get to see it there. You get the main engine cutting off, and then all of a sudden, there's some things that you can't see on this camera shot looking down. The rocket does a couple things. You're going to see the upper stage separate. That means the second stage sort of separates from the booster, the parts that's going to come back down to land at the Cape. And the second stage is going to continue going on. Also, behind the camera for a minute, the fairings are going to separate. And those are those protective aeroshell fairings up at the top that protect the payloads while you're down in the thick atmosphere. But once you get up high enough, the atmosphere is thin enough, there's not so much air that you can just get rid of the fairing. Don't want to carry the mass of it anymore, but you don't also have to protect your payloads from the atmosphere. And so what you see here all of a sudden is the booster flipping around. Because this is an RTLS, literally stands for return to launch site, right? It's going back to where it came from. It's not going downrange to a drone ship or anything like that. It's going back to the Cape, to a landing pad, call it LZ. This one's going to LZ1, that's just a couple miles away from where it launched. So here, you see it flip around because right now, it's still ballistically falling away from the launch site. And it needs to turn around if it's going to end up back where it started. So it does this flip. You see these cold gas thrusters sort of spewing out the sides, and that gives it a little bit of force up at the top of the rocket to help flip the rocket around backwards. Once it gets flipped around, it literally did about a 180 there. Once it gets flipped around, it ignites the engines again. Not all of them, just a couple of them. And it does what's called a boost back burn. The boost back burn actually keeps it from falling downrange. It stops its progress downrange, and it starts to turn it around so it starts to fall back towards the Cape instead of falling onwards to the ocean, down where the drone ship would normally be if it was a drone ship landing. After the engine stops, you can actually see the grid fins deploy. Up at the top of the Falcon 9, there's 4 grid fins that sort of stick out to the side. They almost look like little flippers, right? The trick is, up high, there's not a lot of atmosphere. So the grid fins don't really have anything to push against. They have air flowing through them, but when there's no air, the grid fins are just sort of out. They become more and more important the lower into the atmosphere that the rocket gets. As you get closer down to sea level, there's more air molecules to flow around the grid fins, and that allows the grid fins to, you'll see them turn side to side like this and help direct the rocket without expending fuel. You can see the entire coast of Florida here. You see the Cape, the bump of the Cape. That's literally the Cape. The Cape is the part of the land that sticks out from the normal coast. That's why it's called a Cape. Right there between the grid fin and the body, you can actually see Port Canaveral, where the cruise ships come in and where the stages that end up on drone ships come back in if you've seen any of our fleet cam videos. You can also see other parts of Cape Canaveral Space Force Station, and then all of a sudden, you get the supersonic retropropulsion, the entry burn. That is the atmosphere starting to get thick, and so Falcon 9 fires up more engines to start to slow down and aim at the landing pad. It's not quite there yet, but it's helping slow itself down before it gets into the thicker atmosphere. Now watch closely when they do the entry burn here. You'll see one engine light, and the flames get bigger as they light 2 more engines just like before, and then you get shut down. All right. Now here's something that we always get in the comments. This thing over here, that's actually a piece of ice. Whenever we get the thrusters firing, whenever we get the engines start to light up again, there are little bits of ice that have formed on the outside of the pipes and tubes and things like that. And when they get this force of the engines firing up, sometimes it knocks a couple little chunks of ice loose. There's also stiffener rings. There's a couple different things that come off the rocket. Stiffener rings on the second stage on the way to orbit. But all the time we get people in the comments saying, oh, geez, UFO. It's like everything can be a UFO if you're really bad at identifying flying objects. That one was ice. Now the Cape gets closer and closer in the rearview mirror. Remember, the camera's looking down and the rocket's sort of going down towards the LZ. Pretty soon, a lot more quickly than you might think, the round LZs appear. It's going for LZ-1 for this landing, and they used to have the SpaceX logo on them. I'm not sure they still have this. Maybe they kind of have the SpaceX logo. But here you'll see the final burns. This is the landing burn, when the engines light one more time and they help guide the rocket right down to the landing pad.